Okay, so I'd like to dedicate a topic for today is JSON to object, which we started last week. This is a hard concept, but if you follow my lecture and follow the example, and later when you're doing homework and final project, you will learn well in this concept. Nobody can get this right, even myself. Well, on the other hand, I have to say I developed the concept myself, so that's why it's kind of unique. Dump to JSON and JSON to object is probably um, a particular piece of work that I developed over the year when I realized I want to connect the so-called unstructured data and structured data together. It's an advanced concept, but I want to give you as a challenge for you to learn this concept. Okay, so to just recap a little bit, indeed there are multiple object representation, but in this class, I covered two of them. One is JSON, which is hopefully you already know what it is, and then the other one, of course, is C++. You will see that when I talk about class, I'm using C++. When we talk about object, I actually prefer using JSON to represent the object because it is more readable. I don't have to write the whole piece of code for me to see the object itself, and I can specify the object using JSON. But with the idea of JSON to object, then this really complete the whole roadmap, which means that when I design a system, I can use JSON. And then I develop something called JSON to object, then I can convert the object to C++. Um, in the future, we might be able to convert directly into the C++ code, not just C++ object, but C++ code, which is, you will see a lot of this generative programming tool that will come out. So let me just tell you this too, and you know what it is. And then based on this concept, there is a lot of things you can do with this. So first I said JSON is unstructured and C++ usually we think is structured, but it's you could have more complicated structure, but it's some kind of structure. So here is a definition about well, a description about structured versus unstructured data from the web. I quote from the URL below. So let me read it to you. Is data can be broadly thought of as two different types, structured data and unstructured data. Structured data is data that is stored sets of table with rows and columns. Think of Excel spreadsheets or CSV files. Or the other example is, of course, SQL. The data might be spread over multiple sheets, but by using indexes, you can connect the data together. So essentially, what we're saying is that all the data you can represent with the tabular form, represent as tables. That's what we call structured data. Now we'll talk about unstructured data. Unstructured data is data that is not stored in a tabular format, meaning that it cons isn't considered into a set of table. A common example of unstructured data is data stored in JSON files. A JSON object has property within it that themselves are JSON object, creating more of a hierarchical structure. So this basically represent a typical example when we say it's a structured versus unstructured data. But one of the things I want you to, you already probably notice is whether you're using table or not table. And the typical example about unstructured data is JSON. So in data representation, unstructured data, in fact, is the dominant type about the data we're processing today. As I said, most of the major services, Google, Facebook, they're all using JSON to represent the data. The reason it is the primary choice for all this popular service is that it can easily represent all kinds of data you want. You can add something to it. You can remove something to it. You can just fulfill something which you would like to capture, and without worry about the completeness about the whole things you want to represent, which is really useful for us to deal with the situation that we're not exactly sure what kind of data do we have, but we know we have this and this and this, and then we can just using JSON to represent the data, and we can start our application. We can start processing that. You can process a JSON object, which is with lots of attribute, but you could potentially just process JSON with only a few of them. Okay, so of course, what we're talking about when we're talking about the two representation JSON and C++, that they're quite different in the way that JSON is very flexible. You can have everything. You can have only a few things. You can have a new thing. You can have an old thing. But the C++ class, on the other hand, is very static, very structured in a way that once you go through the compiler process, the structure has been fixed during the compiling process. So that's why it's both useful, different application. It will be great that we can have both. So JSON to object is a particular tool, a particular methodology that we can try to combine this two world together. Okay, so I already talked about dump to JSON. So dump to JSON is converting a C++ object to a JSON object. So that's to be honest, easier because if you want to start it with something which is very static and you want to convert something which is dynamics, that's fine because the you just represent everything is static over dynamic. Well, however, JSON to object become a lot more challenging because we're converting something which is quite dynamic, it's changing. It has new attribute, it has missing record, and then we want to convert it to something which is static. Okay, so this is not well. I said in some sense they're equivalent hard because you are converting one way to the other. But I would say that when you're doing JSON to object, you you encounter a situation due to the nature of unstructured data. Okay, so I want to tell you that okay, under the our EE1520 master page, I have a lots of example about JSON to objects. So let me just get back to you. If you go to, okay, GitHub. If you go to this one, okay, this link, uh, github.com sfelixwu E1520S 2025 underscore project base. And over there, you have a lots of file. I mean, just pick up something very quickly. Let's pick up comment. If you go to comment.h, you will see that, I mean, every single class, with maybe one or two exception, that they have a two virtual function, which is dump to JSON and JSON to object. All of them have this. And then the source code is under comment.cpp. If you keep going down, Wait a minute. Yeah, here. Here is JSON to object. We went through this. Okay, about line 172, right? It started to see the JSON to object. And last time I mentioned, it's a structure that you have a lot of exception handling you need to worry about. Um, and I will talk about that today lecture. But within each of the function, some of the JSON to object is very simple, but some of the JSON to object is pretty uh, complicated. Like comments, JSON to object is one of the most complicated because a comment has you need to handle person, you need to handle reactions, you need to handle text. And so that's why you need to represent more information. So when you convert it to C++, you need to consider more situation. That's why the code is there. I would recommend all of you spend time, look at least three of them to see each of them how work. I mean, if I were you, I would pick definitely the first one is GPS DD or locatable GPS. Um, label GPS, and then I will pick another one such as person dot h person dot cpp. That's another nice one. And then the other one you might want to pick is either comments or reactions. Okay, comment and reactions, which give you a more complicated example about how this thing should work. Okay. Okay, let me come back here. Okay, so those things are something for you to get a feeling. I mean, read the code, write some test program, and to test it to see how it works, the concept. If you have any question, just ask me. Come to my office hour. I mean, you're more than welcome to do that. Okay, so now here is a little bit things I want to emphasize in this lecture is that I said, well, the JSON object when you input the JSON object into the function JSON to object, the JSON itself is never been syntactically checked like a C++. I mean, in C++, when you define a class, the compiler is going to check everything. For example, it's going to check whether you follow the right syntax and to check whether you use the right keyword. So it's a check such that when you create a C++ object, it's guaranteed that this object has certain property consistently across all the object that's being created by this class. Well, JSON is different. JSON, when they enter, it only check very simple syntax, like whether you put the colon, you put the double quote, you put the curly bracket, you put the bracket correctly. That's only checking in the very simple way about its syntax, but it never check anything to do with the data, such as data type. It's only check whether you have whether you're using string, you're using Boolean, you're using floating point, but that's just the basic type. And in fact, even that you can do whatever you want. Okay, so I would say in the JSON, the if a JSON is a valid JSON, it's only check whether this structure syntax, but nothing to do with the semantics about the data. Okay, so that's why now there is a mismatch because apparently the C++ compiler, like a G++, they actually check more information about the object structure than the JSON. And therefore, when we do JSON to object, we need to uh, perform such checks at runtime. Instead of compiler time, we're doing this in runtime. So another way to put it is that the JSON object, in fact, I would say, is a compiler, but we try to do that at runtime. Okay, so you can call it just-in-time compiler. Try to check an object represent as a JSON format that you actually have certain property that we're expecting. Okay, so therefore, when you send a message, send a JSON into the JSON to object, I'm expecting there was some mistake, there was some error, just like a compiler can check your program and report error. The JSON object will have exactly the same thing. We're going to check for error, but instead of using a parser to check, we're going to use if then else statement as I showed you earlier. I will go back to the example again, but I want to talk about in JSON to object, we only look at two different kind of error that we cover. The first kind of error is that you're missing an attribute, means that you should have an attribute, but you missed it. I mean, for example, if you talk about GPS, you should have latitude. If you miss the latitude, that's an error. Okay, or you're talking about a person should have a name and you don't have a name, that's a missing attribute error. Okay, that's one thing. But the other thing, which is also the JSON to object they need to check, is whether you have the attribute, but you use the wrong data type. For example, latitude, we know latitude should be the data type, it should be a number. But if the JSON that you have a key value pair, which is the key is latitude, but then the value is something else. The value could be a string, which is not a number. The value could be a Boolean, which is not a number. Or the data type for the key latitude is either an object or an array. Then that's actually not the value, not the right data type. So we're going to check on that. Okay, so once we check on all this error, then we need to, just like a compiler, when you do a compiler, you make error, the compiler is display on the window, then you start to figure out what's going on. So in the JSON to object, we also need to report those errors using a mechanism we call exceptional handling, which is now you're saying that, well, what's the exception? Because it's an error that we want to report that exception. Okay, so let me actually first tell you that how the flow about JSON to object, which is the design, is pretty clever in the way that I do not try to parse or try to check the whole JSON at one time. Instead, I try to break the JSON into different portions according to the C++ class that's going to being converted into. I mean, just for example, if you have a post, which is a Facebook post, somebody shares something, and the post will have a bunch of comments. And then the comments, each of the comment will have an author, which is a person. And the person has a location, then you have a GPS DD. So if you take a look at this, is that you have a post, and then inside the post, you have a bunch of comments. And then inside each of the comment, you have a person, and you have something else actually. By the way, you have lots of reaction to that comment, but let's actually just focus on this example in front of us, that each of the comment has one person called author who actually wrote this comment. And then this person has a current location, which is GPSDD. I'm assuming we're using the trackable person, okay, idea. Okay, so so instead of trying to convert the whole JSON into a C++ object, instead what we try to do is that, okay, I try to break it apart such that the post is going to call comment JSON to object. What I'm doing here is that I actually look at my post JSON and I figure out which portion of the JSON, which is sub portion of the JSON belong to comment. Then I'm actually extracting that portion of the JSON and then fit in to another function, which is comment colon colon JSON to object. In the same way, when I look at one particular comment, I extract the portion, the sub portion about the person object out, and then I call the person uh, JSON to object. And finally, within the person, there is a location, so I extract the location part, and then I call the GPS DD JSON to object. So I'm not just calling one JSON to object, but each of the JSON to object is a hierarchy from the highest level, and then it go down. It will call different sub component according to their C++ structure, and then such that I can actually process the whole thing piece by piece. I don't have to handle everything. I mean, just a example before I look at the code. I mean, for example, assuming the comment decide that this portion I put it here is going to call the person JSON to object. So you think about this portion of the object has a name, has a location, assuming I only have this two attribute that's necessary. Okay, okay, now I have to extract the GPS part. So you can see that this green part, latitude and longitude, they are belong to the GPS. And therefore, I'm actually going to call the GPS DD JSON to object according to this. Okay, so this is a high level concept about, okay, I have something which I want to process and I kind of break it. I extract the part that exactly I move down to the next level. So in this way, I can handle very complicated structure, very complicated object-oriented hierarchy. Okay, so let me actually look at the real code for you to actually see what's going on. I'm going to use, let me first use comments. Okay, okay, good. Look at this first. Okay, so comment JSON to object is probably one of the most complicated JSON to object among the whole directory. But I'm going through the part that's related to the person, and I want you to know that how it's related. Okay, so I'm going to Control S to person. Sorry. Okay, so you can see that here is this part. Let me actually get to this part. Okay, let me start it with this part. So this part is basically saying that, okay, the comment, by the way, I should say, what is argument JSON pointer? What is argument JSON pointer? So let's first understand this part. So argument JSON pointer is the JSON object pointer that pointing to the how do I say it? The input to the JSON to object function. So for example, I want to use this as example. So when I call person JSON to object, then the whole purple part, this is a the argument JSON pointer is a pointer pointing to the whole purple session because this represents the whole person object. Okay, so that pointer is pointing to the input. So let me just clarify. The JSON being passed or pass in as a pointer, pass into the JSON to object is exactly the portion of the JSON that's supposed to be handled by the person. And similarly, for GPSDD, the green portion is the portion supposed to handle by the GPSDD JSON to object. Okay, they're just a portion of that. So let's actually get back to the code then. Okay, so in this code, comment JSON to object, that this particular portion is the portion exactly extract from the post that represent a comment. By the way, the post has multiple comment, has an array of comment, and this is just one of the comment. And that whole JSON is ARG JSON PTR. So now, having said that, let's actually come over here. Look at this part. So inside that comment, we have to decide who was the author to for this comment. And in the JSON representation of the Facebook post, is the key is called from. So we follow the face. By the way, the whole session of the code, we follow the Facebook convention about what is the key value and what is the structure they're having. So we're actually pretty close. We're using from. So the first thing I'm checking is that whether the argument JSON pointer, which is the one you just pass in, whether you have the from attribute. Okay, so it's basically you see that. Remember, I said I have a two kind of arrow. One is whether you're missing an attribute, which is if from is null. By the way, this is you might not be familiar with this, but this particular piece of code is actually checking whether you have that attribute or not. Okay, if you have the attribute, then when you say star arg JSON pointer from and then dot is null, that if you have the attribute, this is going to be false. So if you do arg JSON pointer from is null is equal to true, that means I'm sorry, you don't have this key value pair there. And therefore, you know that you're missing one important element. You're going to generate exception. Okay, we're going to talk about that later. But the other thing is I want to check the data type. And the from need to be an object. So from is not a string, not a number, it's an object because I have the whole object about the person I need to deal with. Okay, so this too is checking whether you do have the from. If you pass this exception, which means here you pass, okay, starting here, I will say you passed. You pass the check. Then what I'm doing is that, okay, I'm going to first check that whether the C++ attribute, so now I have to go back to the person. Inside the person.h, I have a corresponding attribute called, wait a minute. No, this is not in person, this is in comment, sorry. Inside the comment, I have a one attribute called person. Sorry, the one attribute called author of the comment. It's a pointer to a person object. Okay, so over here, that by default, before you have anything, this pointer is going to be null. If the pointer is null, then I'm going to create a object, an empty object person. So that's why this author now is a person object, but that person object has nothing. It's a blank object that according to this line. So this line, I actually create the object. Sorry, go back here. I create a blank person. object. Okay, all right. So once you create this object, now you see that what I did, I actually just do this part. I just call this author. Who is this author? It's a person object. And this author pointing to the JSON object because now I want to call the person object. I do have that attribute. I want to call that. But what is the input argument? You see, now this is how I extract this portion. See, what I did is star arg JSON PTR, which is that is the argument that passed into the comments, the comment level of JSON to object. But then I extract the front attribute. I mean, the reason I can do this is because I know front is there. And the second, I know front is an object. So the whole thing over here is an object, is a JSON object represent a portion about a person. That's more or less equivalent to this part I highlighted here. Okay. And then inside here, the thing is, the trick is because in my design, I mean, for some reason, I don't know why I did this. It's probably trying to save some memory. So I pass as a pointer. That's why this is the JSON object. I have to add a M sign in front, that which means that the whole thing is passing as a pointer to the person portion about that JSON object into that. Okay, once you've done that, you're done. You see that I'm passing the JSON object from comment.cpp to the person. So let's actually look at the person level. So inside here, I also have JSON to object. Okay, this is the same thing. Again, now you see the argument JSON pointer, but now it's a little bit different. Now the argument is still called that, but it's actually represent a JSON, only the person portion about that JSON being passed in. Okay, again, this is checking a few things. They're checking VSID, is checking name. Okay, now it's good. If you have a name, then I basically just say, hey, this name, now I don't have to call any further. I just say this name has to be there. I forgot whether I have, oh, I do have a home. The home is the location. Okay, so I do have a home. So let's look at the home. And inside the home, you see what I did is that I actually create a new GPSDD and then I extract the home portion, which is the latitude and longitude, and then I call the GPS DD level of JSON to object. So by looking at this example, that's why I want you to take a look at the comment and look at the person and then to the GPS DD. Okay, of course, GPS DD is the same thing. GPS.cpp. Some to object. Okay, inside here, I'm still checking whether you have a latitude, whether you have a, if you have a latitude, then, I mean, I don't have anything that's object that's smaller than GPS at this moment. So I just directly assign the value into that. Okay, and the same thing for longitude. Okay, so this is the part about how the information is processed. So now we're going to take a look at the how the exception is being handled. So from the previous slide, you probably noticed that when we call JSON to object, we're called level by level. So post JSON to object is going to call comment JSON to object. Comment JSON to object is going to call person JSON to object. And person JSON to object is called GPS DD JSON to object. And in each of the function, you're going to perform the check. If you take a look at the code, it's always checking every single attribute. Okay, so the thing is now we see that we might have error. It's pretty much we always know that the information is not perfect. So we're going to get some kind of error here and there. Okay. So the thing is there are two thoughts I want to share with you. One of the design is that you stop processing JSON whenever you encounter the first error. Okay, the first attribute you miss, don't process, stop, and just throw back whatever you have. Okay, that's one way to handle it. Okay, but that is kind of depending on your application. Some application this makes sense. This is what we call fail stop. When you fail something, you stop immediately. Don't continue to try to handle the rest of the information. That's fail stop. Well, the other way, which in social media, sometimes we realize that sometimes that might not be the best approach. I mean, for example, I know I have a huge JSON, which is represent a post. I know I have lots of error, and I prefer I tell the server one time, the server is going through every single element and tell me all the error, and I can fix it at one time instead of one at a time, which is then that wastes a lot of effort. Okay, and also sometimes it makes sense to have a partial object being extracted through the JSON to object. And therefore, what I have been designing in this code is that we try to, because JSON is unstructured, so we try to handle the information the best we can, to process the best we can, and then we accumulate all the exception, and then we send it to the post level. So essentially, if a post, they might encounter some error in the comment, don't stop. Keep process the person, and you encounter another issue. Don't stop. Keep process the GPS. And so when you're reporting the exception, you're actually accumulating the GPS level, person level, comments level, and probably even post level, all the exception you kind of put them together, and then you report to whoever make the initial call to the JSON to object to basically tell them, hey, here is every single exception we detected when you try to convert this JSON object into a C++ object. So by doing this, we have our own design, which is we can actually handle the exception in a recursive way. Okay, so now I'm going to introduce you these two classes that we designed specifically for this curriculum called, I mean, in this, I used to call it ECS, uh, 36B exception, but now since I'm teaching at NCKU, now I'm calling it EE1520 exception classes. And inside here, I have two subclasses. One is called exception info. One is called E1520 exception. So I want to say what's the difference between these two. So exception info is represent one particular exception element, but E1520 exception is the unit that's collecting all the exception and report it at once. So you can think about exception info, E1520 exception might have a one or more exception info. Okay, have a more element. So let's take a look at the code. So here's the code. First, I want to talk about the relationship. So I define something called class exception info. And inside the other ones, E1520 exception is actually inherit from STD exception. And inside here, what it has is a vector. It's a vector. This is a standard data structure in C++ called vector. I have lots of them, standard template library. And this is an array of exception info pointer. Okay, so essentially, E1520 exception object is a collection of a bunch of an array of exception info. Okay, and of course I have a bunch of function over here. So let's actually then the trick is this class is exception info, what it is. Okay, so let's take a look at what it is. Exception info has where, what, which, how, and array index. And also I have a operator overloading on assignment, which is very useful when I try to concatenate exception information together. So let's actually take a look at the where, what, which, how, and array index. I forgot why I have array index, by the way, but it's recording where, what, which, and how. So let me show you an example. Let's actually take a look at the comment. Okay, inside JSON to object, let's use a different yeah, this is fine. I'm just using this. It's fine. So I'm checking whether this comment has the ID. Okay, so look at this. I actually, if I realize you don't have ID, or your ID in the wrong type. It's always two, whether you have this attribute or whether your data type for the attribute is actually accurate. So what I did is I create a new exception info because I'm going to accumulate. Remember, I'm going to accumulate. So that's why I have to create a new one. But once I create new one, I say where is the class? The class is comment. So by the way, I define a lot of macro. All the macro is in E1520, comma. Wait a minute. What is this? Yeah, dot H. I believe it's dot H. Okay, inside, I say S JSON to object. Okay, you see that? I have a bunch of JSON to object flag. And one of them is comment. Okay, I define a bunch of those. So basically, when I say where code, that means this code represent, okay, you have a problem, and this problem is actually inside the comment class. Okay, inside the JSON to object comment. Okay, that's what this. So you can see that I define pretty much everything. Everything has a flag for that. Okay. And which string I basically encoded is a string. Which string is an ID because I'm missing ID, so I have this. Okay, no, I have one more thing I need to worry about. Sorry. Go back here. And inside the how code, I just basically by the way, how I don't know exactly how to use it. But there is a one more is what is the error? Why is the error? I'm checking whether your key missing, you're missing an attribute, or you're missing you have the data type mismatch. So you can see that now. Now I'm going back to the where do So look at exception info. I have a four. I'm pretty sure how I'm not using that. I'm not using array index in this case. But I'm using where, what, and which. Which means that what is the attribute I'm interested. And where is which class. In this case is comment. And what is, okay, whether you're the the attribute key missing or is the data type mismatch. Okay, you can have this too. Okay, so this basically record this particular one, and at the end, you see that after I create this, oh, I just always set array index to be 0, and you see that I push back. So this is the exception, LV exception PDR is the data type of E1520 exception. And inside here, it has a vector called info vector. And I push this EI pointer, which I just created, into that. So essentially, you're accumulating this one by one. And this LV pointer at the end, after you accumulate all of them, see, I told you that the comment JSON is the one of the most complicated because it has a lot of stuff you need to worry about. But it's not that hard. It's just because the data complexity. Okay, so now you see that the final one here is that if the LV exception pointer info vector, which is the vector, the size is not equal to 0. By the way, if it's equal to 0, that means there's nobody push back anything into this info vector. So it means you don't have any exception, and therefore you shouldn't do anything. But if the size is greater than sorry, is not equal to 0, which means that you have something, then you're going to throw the whole thing. You're going to throw the whole E1520 exception to the upper level. Okay, so that's the idea. Oh, I know I'm missing one particular things I need to talk about before I finish this lecture. Let's go back to the person, which is the from. Okay, you see that when I decide to handle the from, I have a try clause, right? I have a try clause. I mean, by the way, I should get rid of this. This is distracting. I was doing some debugging a long time ago, and I forgot to remove it. Okay, this part, let's take a look at this part. This part, you see that earlier I said I'm actually calling the JSON to object to the front, to the person's level. Okay, so when I try to pass the JSON, and remember, any JSON to object, they might throw some exception, and therefore I actually try to catch it. Okay, I try to catch it. And then the exception, when I have an exception, what I did, you see, I append the E, which is the new exception that's being generated from the person level. And then I append the person level's exception into the LV exception, the exception that I'm actually going to collecting. Okay, so JSON to object append EI is a function just help me to collect. And where is that defined? I think it's defined in, yes, it's here. It's defined here. You see that has a one, which is argument E and argument exception, and has an array index. And I'm not using array index. So you can see that I'm just basically extracting every single thing from the ARGE. I'm actually getting each of the ARGE and I push back into the ARG exception pointer. So essentially what I did is I take out every single element from the first argument, which is ARGE, and then I push back into the second argument, which is ARG exception pointer. So the second argument is the one I actually keep getting. And after I did all this, by the way, I'm going to destroy the first argument. The exception, after I did the copy, I no longer need it. That's why over here I have to destroy. And I wrote the code I have to destroy using my own code in order to free the memory correctly. By the way, when you handle a huge amount of data, to destroy something is very very important for C++. In Python, you don't have to worry about that. Okay, so hopefully this give you some overview about what I like you to know about this, which is this two class. And I hope you have a good week. I will see you on Thursday.